In this lesson, we are going to be adding, subtracting, and multiplying polynomials. We are going to start with adding polynomials. Please remember that when we are adding, we're simply adding the coefficients and keeping the base. We want to make sure that our final answer is in standard form. So we'll start with our x to the fourth power, remembering that the coefficient of this x to the fourth would be 1, even though it's not written there. So 1x to the fourth plus 2x to the fourth would be 3x to the fourth. Next we take a look for our x cubes. We have a 2x cubed. We don't have any x squareds, and then we don't have any x's, so we're going to lastly combine our constant terms together. 8 minus 9 would be negative 1. That is simplified and in standard form. Next we're going to review subtraction. Now there's a couple of different ways to do it. You can just simply subtract by saying 9x to the fourth minus 3x to the fourth, negative 12x cubed minus a negative 12x cubed, and so forth. What I like to do is to change this to addition and then add the opposite of each term so that I get the signs correct each time. So I'll change these both to plus. So we're going to start by adding 9x to the fourth and negative 3x to the fourth, which gives us 6x to the fourth. And then we'll look for our x cubes. I have a negative 12x cubed and a positive 12x cubed, which would have a sum of 0. I have an x squared, so that'll be plus x squared. I have an x, so that'll be plus x. And lastly, my constant term will be minus 8. So this would be my solution in standard form. Next, you want to multiply polynomials together, and in this example we have a binomial times a trinomial. The biggest hint I have for you is to just make sure that you're organized when you are multiplying so you don't forget anything. So we're going to multiply the x times each of the elements in the trinomial, and then we'll multiply the 1 times each of the elements in the trinomial. So I have an x cubed plus an x squared minus an x. Then I'm going to multiply the 1 times each of the elements in this trinomial. So I have an x squared, an x, and a negative 1. And then we're going to combine like terms, writing our final answer in standard form. So we have x cubed, and then I have a 1x squared and a 1x squared, which would be 2x squared. I have a negative x and a positive x, which will have a sum of 0. And then we have the constant term, which will be minus 1. So that's our polynomial solution in standard form. Let's do a couple more examples with multiplication. So now we have 3 binomials that we are multiplying together. And when we do that, we want to make sure to simply do 2 at a time. We'll get our product, and then we want to multiply that times the last binomial. So x minus 2 times x minus 1, we're going to FOIL that, and so we have x squared minus x minus 2x plus 2, and when I combine like terms, I have x squared minus 3x plus 2, and that is my trinomial. And then I'm going to multiply that times my binomial. So when we do that again, we want to make sure that we keep organized, so I can multiply the x squared times each of the terms in the binomial, the negative 3x times each, and the 2 times each of those. So x squared times x would give me x cubed, and then x squared times 3 will give me 3x squared. Negative 3x times x squared gives me a negative 3x squared, and negative 3x times 3 is a negative 9x. 2 times x and 2 times 3 would be 6. Now we'll combine like terms. We have an x cubed, 3x squared, and a negative 3x squared have a sum of 0. Negative 9x plus 2x gives me negative 7x. And finally, I have my constant term, which is 6. So this would be my simplified form in standard form. Let's review multiplying 2 binomials together. So we have the 3x minus 2 and the 3x plus 2. Now remember that we can just simply FOIL these out. And so we have a 9x squared, and we have positive 6x minus 6x minus 4. With our middle terms having a sum of 0, we have 9x squared minus 4. Remember, that's the special pattern called the difference of squares. So if you recognize that special pattern and you remember that the middle terms will have a sum of 0, you really only need to do the f, or multiply the first terms together, and the l, or multiply the last two terms together. In the next example, when we have 5a plus 2, the biggest mistake people make is simply to bring the exponent inside and to only square these two terms. But when we are squaring this binomial, we need to remember that this actually means the binomial times itself. And so there are more terms than just 2. So when we FOIL this, we have 25a squared plus 10a plus 10a plus 4. So when we combine like terms and our final answer is written in standard form, we have 25a squared plus 20a plus 4. And that is called a perfect square trinomial. There is a shortcut, if you wish, into getting that final answer. If you simply square the first term, which is 25a squared, square the last term, which is 4, and then to get our middle term, or the o and the I, we simply multiply the two terms together. 5a plus 2 is 10a, and I know that I would have two of those terms, or I need to double that answer to get my middle term, which is 20a. In our next example, we have our binomial being cubed, which means we have 3 sets of this binomial. So, as we discussed before, we can multiply 2 at a time together, FOIL those, and then multiply by the third. So we have 4m squared minus 6m minus 6m plus 9, which is 4m squared minus 12m plus 9. Or, taking the shortcut, this would be the perfect square trinomial, which means I could multiply 2m times 2m to get 4m squared, negative 3 times negative 3 to get 9, 2m times negative 3 gives me negative 6, and then I need to double that. So what we need to do next is to multiply that perfect square trinomial times 2m minus 3. So 4m squared times 2m will be 8m cubed minus 12m squared minus 24m squared plus 36m plus 18m minus 27. So when I combine like terms, I'm going to have 8m cubed, I have negative 12m squared and a negative 24m squared, which gives me negative 36m squared. 36m and 18m combined together will give me 54m, and then my constant term is minus 27. There is a special pattern with letter C and D. It is called the cube of a binomial. So when you have your a minus b cubed, if you cube the first term, so 2m to the third power would be 8m cubed, and then you subtract, first of all taking a squared, 2m times 2m would be 4m squared, and multiply that by 3. And then multiply it by b, which would be 3. That would give you the negative 36m squared. And then you can take 3 times 2m would be 6m, times 9 would be 54m, and then subtract the b cubed, which would be 27. If you would like to take a look and use this pattern, you can as well. Or you can multiply all of it out if that is easier for you. So in this example, we'd have x plus m cubed, which means that there are 3 of those binomials together. And you can multiply the whole thing out if you would like, first multiplying x plus 7 times x plus 7, which would be x squared plus 14x plus 49, and then multiplying that times x plus 7. Or if you'd like to use the pattern a plus b, the quantity cubed, the first thing you're going to do is cube the a, which is going to be x cubed. Then take a squared, which would in our case is x squared, times b is 7, and multiply that by 3, and that gives us 21x squared. The fourth term is a times b squared, which is 49x times 3, which would be 147x. And then lastly, we're going to add b cubed, which is 7 times 7 times 7, which is 343. Either method works, and you'll get the same answer. Next, here I have the whole chart for you of special products, which would be your sum and difference, your square of binomial, and then what's more, the cube of a binomial, if you would like to look at those special patterns. Remember when you are adding, subtracting polynomials that you are actually combining like terms, and be sure to put your final answer in standard form. Be careful of the signs, and then always make sure to multiply the polynomials carefully and do it in an orderly fashion.